quotient of powers property. So we've been talking a lot about multiplying. Let's take a look at how dividing works with our powers. So quotient of powers property. To divide powers of the same base, keep the base in the numerator and subtract the exponent. So when we're talking about a quotient of powers, we're going to be looking at a fraction. So what I'm going to do is I realize that these two have the same base. Again, just like multiplying, they have to have the same base in order for this to work. So they have the same base. I'm going to keep that base in the numerator. So here's my 4 in the numerator. And I'm going to subtract their exponents. And we subtract just like we subtract normally. I go down. So my top exponent minus my bottom exponent. So 5 minus 2. So I come up with 4 to the third power. That's technically in the numerator, but we don't really generally write over 1 anymore. So it is 4 to the third power. So let's put this into action. Simplify, write your answer as a power. So we can leave our answers as powers here. So 9 to the 7th over 9 to the 4th. Again, they have the same base. So I'm going to keep that base in my numerator. It's a 9. And I'm going to do 7 minus 4, and I get 3. So really this is 9 to the third power over 1. But again, we don't really write it like that, so it's just 9 to the third power. Next, I have 4.2 to the 6th power over 4.2 to the 5th power. Again, these are the same base. So I'm going to keep that base in my numerator. This is over 1. And I'm going to subtract my exponent. 6 minus 5 gives me 1. 4.2 to the first power. We don't really need to write to the first power. Again, that's another case of where the 1 we don't need to write. And I end up with 4.2, 4 and 2 tenths. And C, x to the 8th power over x to the third power. Again, my bases are the same, so I can use this rule. I'm going to take my base and keep it in the numerator. Again, this is x to the 5th over 1, but we don't write that. And I'm going to do 8 minus 3, which gives me that exponent of 5. All right, let's take a look at a few more. So now what we're going to start to do is combine all of these rules that we've been working on together. So we're going to talk about the multiplying and the dividing, so our products and our quotients, kind of all in the same expression. So we're going to simplify each of these. So I have 2 to the 5th power over 2 to the 3rd times 2 to the 5th. So in my denominator here, since they have the same base, I can multiply them by keeping the base and adding the exponents. So I'm going to keep the 2, and I'm going to add the exponents. 3 plus 5 gives me 8. So I have 2 to the 15th over 2 to the 8. Here they have the same base, so I can keep the base in the numerator and subtract the exponents. So 15 minus 8 gives me 7. So I have 2 to the 7th power for the simplified version of that expression. Next, I'm doing a fraction times a fraction. So we know fractions times fractions. I do numerator times numerator, denominator times denominator. So d to the 5th times d to the 9th is d to the 14th. And this is d to the 1st. Don't forget that that's invisible 1 again. d to the 1st times d to the 8th is d to the 9th. So now I'm going to simplify this because they have the same base. So again, I'm going to keep that base in my numerator, and I'm going to subtract my exponents. 14 minus 9 gives me d to the 5th. All right, one more like this. I have 5 to the 9th over 5 to the 4th times 5 to the 5th over 5 to the 2nd. So again, I can multiply across. So I have 5 to the 9th times 5 to the 5th. Same base, I'm going to keep that. And I'm going to add the exponents, 5 to the 14th. My denominator has the same base, so I'm going to keep that base and add the exponents. So I have 5 to the 6th in my denominator. And again, I've got the same base here, so I'm going to keep that base in my numerator and subtract my exponents, and I come up with 8. So I end up with 5 to the 8th power for the simplified version of that fraction multiplication expression. Last one, let's take a look at a word problem here. So the projected population of Alabama in 2030 is about 2 and 2500ths times 2 to the 21st power. The land area of Alabama is about 2 to the 17th power square kilometers. Predict the average number of people per square kilometer in 2030. So again, when I look at these, I kind of look at these numbers and go, what do they want me to do? So I'm going to make these numbers a little bit simpler just to figure out what they want from me. So the projected population of Alabama in 2030 is about, I'm going to say it's 1,000. I'm going to pick a friendly number here. So imagine there's going to be 1,000 people in Alabama. That's not very many people, but just pretend, just to pick some numbers that I can comfortably work with. So it's about 1,000. The land area of Alabama is about 2 square kilometers. So let's say the whole of Alabama is 2 square kilometers. I've got 1,000 people. They're going to live in 2 square kilometers. Predict the average number of people per square kilometer. So I want people per kilometer. So I need to do how many people there are divided by the number of kilometers that there are. So that's my plan. My plan is take how many people, divide it by how many kilometers there are. Now in this case, I have this one crazy number of people. So I'm going to use that in my numerator. And I'm going to divide that by how many kilometers there are, my 2 to the 17th. So I'm still doing division. I already decided kind of using my simpler numbers that we're going to divide, but now I'm going to put my crazy numbers back in there. So I've got 2 and 2500ths times 2 to the 21st power over 2 to the 17th. Now these two have common bases. They have the same base, so I can simplify them. So I'm going to keep the 2 in my numerator, excuse me, with my 2.25, and 21 minus 17 is 4. So I have 2.25 times 2 to the 4th power. 2 to the 4th power is 16. So I grab my calculator and do 2.25 times 16. Sorry about that. And I end up with 36. So it's going to be about 36 people per square kilometer in Alabama in 2030.